let's take a look at one of the most important features or abilities of a graphing calculator, any graphing calculator, and that is it allows you to approximately solve any equation in a single variable. For example, suppose we have something like this. Solve for x, and we have a rational equation. X squared minus x minus 3 over x squared minus 1 equals 4 minus x squared. Now, to do this algebraically, you might remember that you need to clear fractions, so you'll cross multiply. Then you'll have to FOIL out the right side. Then you'd have to collect all the variables to one side and set it equal to 0 because it's a fourth degree polynomial that you'll have. And then see if you can factor that fourth degree polynomial, or if not, look for approximate solutions. Well, we can look for approximate solutions right away if we think of the left side and the right side of an equation as separate functions. We have a function, x squared minus x minus 3 over x squared minus 1, and we have a second function, 4 minus x squared. To find out where they are equal, we look at the places where the graphs of the left and the right side functions intersect each other. So let's take a look at GeoGebra and see how we do this. We'll take the first function, we'll call it L of x, equals, and we want it to equal the left side of this equation. So we want it to equal x squared minus x minus 3 over x squared minus 1. Now, on a graphing calculator, things are usually written on a single line, so you need parentheses to show the start and end of a fraction bar. So we'll have a parentheses, x squared minus x minus 3, end parentheses, that's the top of the fraction, divided by now parentheses for the bottom of the fraction, x squared minus 1. And remember that exponents are those little up arrows. So we put that in, we hit enter, and we have a rational function. We'll learn about those in chapter 4, but right now just know that this is the graph of L of x. Now let's type in the right side. We'll call it right, R of x equals 4 minus x squared. Enter. There we go. Now, as you may or may not recall, or as we'll learn in chapter 3 and chapter 4, when we have a fourth degree polynomial, we can expect as many as 4 unique solutions. And in fact, we see 4 solutions right here. They cross 1, 2, 3, 4 different places. What do we want to know about those? We want to know how much x is because we're solving for x. So all we're concerned with is the x coordinate of the solution. Let's get enough decimal places of accuracy. We go to options, rounding. Let's go to 5. And now I want to find where these intersect. On GeoGebra, we look for the intersection of 2 objects, and that's under the point button down to intersect 2 objects. We click on the 2 objects near the place where they intersect and see what we get for an answer. We get one possibility. X is negative 1.76401. We get another possibility. We get the third possibility. And we get the fourth one. Here are the 4 different answers. Remember, we can ignore the y coordinate. That's just going to come out the same on left and right sides. We want to know what x is. So our 4 answers to this problem, if we were asked to solve it for x, we would say x equals, and type in the 4 different things. Negative 1.76 rounded to 2 places. X equals negative 0.69, x equals 0.340, and x equals 2.06. So again, anytime you want to solve an equation for a single variable, you can let one function be the entire left side of the equals sign, let the other function be the entire right side of the equals sign, search for the places where the graphs cross each other, and then automatically the x-coordinates of those intersections will be the solutions to the equation.